Alright, here's the next one. I'm going to change it up a little bit with the background color. I don't like the white so much. I prefer the black because all the colors tend to show up easier. So we'll stick with the black for a while. Now, let's do the next topic, which is to evaluate numerical expressions. Just put that topic heading here. Evaluating numerical expressions. Alright, so we're going to be evaluating numerical expressions. I'm going to change this to blue. Like that. No, change it to green. Alright, so we're going to be evaluating numerical expressions. And the objective for now, well, for this lesson, is the objective is to evaluate numerical expressions using any of the four basic operations on real numbers. Right, so that's the objective that we're going to be doing today. Right, evaluate numerical expressions using any of the four basic operations on real numbers. Now, the first thing that you need to do when you're performing any kind of operation or you're working out any kind of operation is that you must remember the order of the operation. So we're going to start off with the order of operations. The order of the operations is important because if you don't perform the operations in proper order, then you're not going to get the problem correct. You're not going to solve the problem correctly. Now, there are two common sentences that you would tend to use when it comes to remembering the order of the operations, and I'll write those two now. So there are two common sentences used to remember the order of operations. The first one is, please excuse my dear Aunt Sally, which is PEMDAS, PEMDAS. And the other one, which is what I prefer to use most of the time, is big old dogs making a scene. And that is BUDMAS. Right? Both of them will be used to deal with the order of the operations. And what we're going to do is we're going to be using these first letters. So this P here, this E here, this M, this D, this A, and this S to figure out the order of the operations for using PEMDAS. And then we're going to use the B, the O, the D, the M, the A, and the S for BUDMAS to remember the order. All right. So let's talk about BUDMAS versus PEMDAS. All right. So we just do this here, and we're saying PEMDAS versus BUDMAS. Right. Now, it doesn't matter which one you use because when you're going through the process, the order for the divisions and the multiplications doesn't matter. It's just a matter of which one you see first when you're reading from left to right. So when you're seeing here how the M, I'm just writing it with a different color. Now that you're seeing here with the M and the D, and then you have the D and the M, it doesn't matter which one you do first. So long as it is that you do them from left to right. Okay, so let me just put the rules here for you so that you can see exactly what it is you have to do. And I'll just go with the first rule. I'll put this in white. So thanks. All right, so the first rule is parentheses parentheses from the PEMDAS and the brackets from the BODMAS are the same and include all types of brackets. Alright, so that's the first one, parentheses. The parentheses are going to be either parentheses or brackets. That's the first thing you evaluate. So inside any operation, if you have parentheses or brackets, what you're going to do is you're going to include the rest of PEMDAS, you're going to apply the rest of PEMDAS or BODMAS to the inside of that bracket, and then you're going to work the externals of that bracket. And you will see a little bit more about that later when I give you an example. So the first thing, remember, we deal with any brackets. We apply PEMDAS or BODMAS on the inside of every bracket. Okay, so that's this one. Let me go with number 2. And we're looking at E in PEMDAS, which is exponents, right? PEMDAS, and orders in the BODMAS, right? This covers powers and roots, right? So the next thing that you deal with after you deal with all the brackets, after you identify the innermost bracket that needs to be dealt with, you're going to be looking at the exponents inside of there. You're going to see about the exponents or the powers, and this includes your powers and your square roots. So you deal with those exponents and then you move on to the next thing, 3, which is multiplication and division, right? It does not matter, right? It does not matter which you perform first, so long as you apply it from left to right, right? So whatever multiplication that you have to do or whatever division that you have to do, as you go from left to right, if you encounter multiplication, you do the multiplication first. If you encounter division, you do the division first. It doesn't matter. As long as you're reading it from left to right and you come across either a multiplication or a division, you do that operation. And then the fourth and final one, which is the addition and subtraction, it does not matter which you perform first, so long as you apply it from left to right. Right? So as long as you're doing it from left to right, that's it. That's all you need to concern yourself with. And let me give you an example of what I'm talking about. Right? So let's say example, and let's say we have 2 times 4 divided by 2 plus 3 open bracket 2 times 3, put times already, let's say 3 divided by 6 times 6 close bracket. Alright, so we're reading from left to right and I identify the brackets first, so I have to solve inside of here first. Alright, I have to solve inside of here first. So when I solve inside of here, I'm just going to write it in yellow. I'm going to take my 3 and divide it by 6. 3 divided by 6 is going to be equal to half. And then I'm going to multiply it by 6. So when I multiply it by 6, it's 2 cancels with the 6 to give me 3. And 1 by 3 is 3. So this here works out to be 3. And when I rewrite the entire thing, I will have 2 times 4 divided by 2 plus 3. That open bracket there is a multiplication, and we have 3 inside of that bracket, so I'm just going to replace that with a 3. And then moving from left to right again is what I read. So I have divisions and multiplications occurring all over the place inside of this, but I have to apply it from left to right. So I'm going to go 2 times 4 is 8. So I put that 8 first, and then I put down the rest. Divide by 2 plus 3 times, and this 3 came from the bracket. And then I do the division, so 8 divided by 2 is 4. 8 divided by 2 is 4, so I'm going to put 4 here. Then I'm going to put down the remainder, so this is plus 3 and then times 3. Right? Now this is the other, this is an addition, so I don't do the addition yet. I have to do the other multiplication first. So I'm going to do the multiplication, so that's 3 times 3, which is 9. So I'm going to have here 9, and then I have 4 plus 9, and 4 plus 9 is going to be equal to 13. Right? So that's the order of the operations. You go into the brackets first, and you apply everything, you apply the remaining 3 rules to inside or the innermost bracket. You solve that, and once you solve that, you use that value outside to solve the rest. So you solve brackets first, then you deal with any exponents, then you deal with any multiplication and division, and then you deal with
what I
any
did here is
I showed you the order of the operations. You're already supposed to know how to do these basic operations. All right, you're already supposed to know how to do the basic operations, but I'm still going to run through it quickly so that you can get a reminder of your primary school work. So I'm just going to write this in yellow here, basic operations. Right, these are the basic operations that you're supposed to know already. Let's do it with addition. And we're going to start off with whole numbers. And the example is 6 plus 7 equals 13. Now, when you have to add something bigger, let's say 13 plus 22, what we're going to do is just simply line them up with the decimal points. We're going to add here, so this here, this 2 and this 1 is 3, and I put a 0 here, and then this 2 and this 3 will make 5, and I put that there, add that, 30 plus 5, 35. Now, I know that this is a longer way to do it, but when it gets more complicated, when it is that you have larger numbers, you're able to faster add these together by thinking in terms of tens. All right, so that's why I did it like that right now. Next, we go to fractions. So we need to know how to add fractions. And the example that I'm going to use, let's say a half plus 1/3, and we're going to write the denominators as something that they have in common. So we want a lowest common multiple for 2 and 3. So the lowest multiple that we have in common to 2 and 3. And if you do the LCM, or if you're able to identify LCM, you would know that the lowest common multiple to 2 is 6. Right? And the lowest common multiple to 3 is also 6. So what I'm going to do is I'm going to just write this. This is what I'm doing in my head when I'm doing an addition of fractions. So I'm seeing a half, but what I'm going to do is I'm going to multiply the top. Sorry, I'm going to multiply the bottom by the number that gives me 6, and I'm going to multiply the top by that same number. I'm going to do the exact same thing for the other 1/3. To get 6, I'm going to need to multiply 3 by 2. So I'm going to multiply the top by 2 as well. And I will explain this concept a little bit later. Now, once I have that, 1 by 3 on top is 3, and 2 by 3 on the underneath is 6, plus 1 by 2 on top is 2, and 3 by 2 is 6. This gives me 5/6, and that's the answer for the fraction. So what you're going to do when you're solving fractions is you're going to find a common denominator, then add the numerators. Right? That's what you're going to do when it comes to the addition of fractions. Then we have the decimal form. Decimal. And for the decimal form, we will use something like, example, let's say 3.5 plus 2.75. Let me write that plus properly. And that would be equivalent to something like this. Let me just write it on the side. So I'll 3.5, and I'm going to line up the decimal point. So 2.75, and then I'm going to do the normal addition that I did previously. So 3 and 2 is 5. Put a point and then put a 0, 0 at the end. 7 and 5 is 12. So I'm going to put 1, put a point, a 2, and a 0 at the end. 5, just have that 5 there. And notice that when I add it, 5 and 1 is 6. 2 and 0 is 2, and then 5, 0, and 0 is just simply 5. So 6.25. We get 6.25. All right. Next, so actually, you know what? Let me put a little note for that addition there one time as well. Yeah, let's go a little note here for that one. So the little note would be to align the decimal points and then add. Right? So that's what we do for decimals. All right, let's go on to the next operation that you're supposed to know from primary school, which is, I think I just, all right. And the next operation you're supposed to know from primary school is subtraction. So subtraction is simply done the same way that you do in primary school. Whole numbers. All right, so whole numbers, we are looking at, let's say an example. Let's say we have 9 minus 5, we'll get 4, right? So you just subtract the numbers directly, okay? Then we have fractions. Now, fractions is just the same thing that we did previously for the addition. It's just that we're doing an addition or removal instead of an addition. So let's say, for example, we have something like 3 over 4 minus 1 over 2. Now, the LCM of 4 and 2 is 4. So I don't need to multiply this, so I can write this back as it is. Put back the operation, and then what I need to do is I need to multiply 2 by 2 to get 4. So I'm going to have to multiply the top by 2. So I'm going to get 1 by 2, which is, so this 1 by 2 is 2, and then this 2 by 2 is going to be 4. So 3 minus 2 is going to be 1 out of 4. Right? So remember, all this really means is that you're making sure that when you do this, you're making sure that you have the same amount of parts in the fraction. So 3 parts out of 4, 1 part out of 2. So I'm going to break this further 2 parts up into, I'm going to break it up into 4 parts, and then it's going to be 2 parts out of 4 to be given me the same thing here, the same fraction we have. So I get my quarter. So same thing that you do for addition, is just that the symbol is different. Then we were looking at the decimals for it, and again, similar to the additions, all we're doing is we're lining it up. So if my example is 5.7 minus 2.4, we align the decimal point. So 5.7, 2.4, and we just do the subtraction. So 5 minus 2 is going to be 3, put the point 0 here, and then add this, and 7 minus 4 is going to be 3. So I'm going to get 0.3 here, and then I add them together, 3.3. Now this example is not nice, because what happens if it is that the number on top is big? And I know you'll probably see that kind of thing. Let me just give you another example right away. So example, let's say we have 2.2 and we minus in 3.6, right? This answer you know is going to be negative. We know it's going to be negative, so we say in 2.2 minus 3.6, right? So we say 2 minus 3 is going to be minus 1, minus 1.0, and then 2 minus 6 is going to be minus 4. So we're going to have here, we're going to add a negative 0.4 here. And this here all simply works out to be minus, and this here combines to be a minus. So we have this minus this, which is negative 1.4. All right. Another way you could have thought of it is like this, which is take the 3.6 minus 2.2, and you have gotten 1.4 here as well. But recognize that you switch the position of this to the front with the minus sign. So that means your answer is going to have to be negative to account for that. All right, so if you switch to the front and you do the subtractions, you're going to have to account for that by putting a negative sign in front of your answer. So your answer is going to be negative 1.4. Next is what? Multiplication. Right? Multiplication of whole numbers. Multiplication of whole numbers, let's say example is 3 times 4, that'll be 12. And that is something you should think about in terms of 1, 2, 3. So we have 4 rows. Well, actually, you know what? Let's say it's rows by column. So I have 3 rows of 4. Right? If I have 3 rows of 4, how many do I have? It's 12. Again, this is something you should know from primary school, so shouldn't be too much of an issue for you to follow. So we have 3 rows, 1, 2, 3, 4 columns, 1, 2, 3, 4, and the multiplication is just the total amount of blocks inside of here, which is 12. All right. Let's go on to fractions. Whole numbers for fractions. The example. Let's say you have 2 over 3 actually. Let's say 2 over 3, smaller fractions. Multiply by, let's say, 3 over 4. Then there are 2 possible ways that you can do this. All right. In this case, we can first, let me do 2 options. Right. So I'll just do 2 options right away. So I'll do different colors for each of them. So I can directly multiply the top by the top and the bottom by the bottom. So 2 times 3 divided by 3 times 4. I can directly do that, and I will get 6 over 12, right? And then I have to reduce the fraction since there is a factor common to both the top and the bottom, and that factor is 3. So if I take 6 and I divide it by 3, I'm going to get 2. And if I take 12 and I divide it by 3, I'm going to get 4. And then I have the other common factor, which is 2. So I have 1 and 2. So I get a half. And yes, I know you can just directly divide by 6 in the beginning here and divide by 6 here. And then you go straight to the answer at the end, which is the half. That is fine as well. I don't mind. Right? I'm just doing it for, I just like to do it slow. Right? Then we have the cancellation method. So we're going to have the 2 over 3 and the 3 over 4, and we're going to cancel any factors that are common to the top and the bottom. So top here and bottom here, 3 divided by 3 is 1, 3 divided by 3 is 1, and then I have the new problem, which is 2 by 1, 1 by 4. I can also cancel the 2 with 2 divided by 2 is 1, and 2 divided by 4 is 2. So I can also replace this here with 1 and 2. And then I would end up 1 by 1, which is 1, and then 1 by 2, which is 2. Right? Notice I get the exact same answer that I have in the other method. So you can do it either way you want. You can multiply the top and the bottom directly and then reduce after, or you can reduce first and then multiply the top and the bottom. Your choice. Whichever makes you happy. All right? Then we have what, decimals now? So fractions, yes. So decimals now. Decimals. All right, let's say the example. Let's say the example is what? 1.2 by 3. We do it the exact same way that we would do any numbers or any large numbers. We say 1.2 multiplied by 3. We're going to say 1 by 3 is 30, 2 by 3 is 6. We're going to add those two together. We get 36. And we're seeing how many spaces the decimal point moved. So we're seeing that the decimal point is one space this way, nothing, and the decimal point would be here, so there's 0 spaces this way. So 1 and 0 is 1, so we just move it 1 this way, and you get 3.6. All right, so the answer for this is 3.6. Okay, so in this one here, what you would do, and I'll put a little note on this one because this one is a little bit different. So we multiply as whole numbers, then place the decimal point in the result. Right, so you count the number of spaces the decimal point needs to move, and then you put it in the result. So in this case, we needed to move the decimal point one space to get 1.2. We didn't need it to move anywhere to get 3. So therefore that answer is 3.6. And let me just do that again in another one. Let me just give another example right away. Right, so let's do another example. Some larger decimals this time. So it's a 2.4 by 2.3. Okay, so we multiply it as whole numbers, 24 by 23. I'm just going to do a little bit of an arrow so that you can see where it is I'm multiplying. So I'm saying 2, let me just write it bigger. So 2, 4, 2, 3. Let me just write it bigger. So I have 2 by 2 here, which is 4. And just put in that 4, and then since it's in the tens position, I have 1, 2 zeros in the tens position. So I just simply put 0, 0. Then I look at these two numbers, which is 6. So 2 3s are 6, and I have 1 0 in this, since one number in the tens position. So since I have one number in tens position, so that's 6 with a 0. So I just put in a 6 with a 0. And then I do the exact same thing, 4 by 2, which is 8, and I have one number in the tens position, which is the 2. So I have one number in the tens position, so 8 with a 0 at the end of it. So 8 with a 0. And then I have the 4 by the 3, which is just simply 12. So I'm just going to put that over here, 12. And then from there, we're going to add, no, I can just add these directly, right? And I will get what, 5, 5, 2. I can add these directly and get 5, 5, 2. But what I can also do is I can reduce the problem a little bit more, right? I can reduce the problem a little bit more, which is I put the 4 here with the 2 zeros. Then I add these numbers together, the 6, the 8, and the 1. The 6, 8, and 1 is 15. So I can put 15 with 1 0, right? Because I'm adding in the tens position. So I get 15 with 1 zeros. This is in the hundredths position, so 4 with 2 zeros. This is in the ones position, so this is just simply 2. And I just simply add these together. I'm going to get 5, 5, 2. All right. Now, we're not finished. I'm looking to see how many decimal places I need to move to get 2.4. So I'm seeing that the number is right. The decimal point is right here. I need to move it one place to get 2.4. And I need to move it one place to get 2.3 from 23. So that is 2 places. So that means I just simply move my decimal point 2 places, 1, 2, and that's going to be 5.25. Sorry, not 5.25, 5.52. 5.52. All right, so let's here be 5.52. Good. All right, so that's that. And then we have the final one, which is division, right? And division is just simply repeated subtraction. So division, we just put that there. Division, right? you can just think of it as repeated subtraction. In other words, how many times can I subtract this number from this number? Right? So in other words, let me do the whole numbers first and you see what I'm talking about. Whole number. Right? Whole number. Let's say, for example, we have 12 divided by 4. All it simply means is how many times can I subtract 4 from 12? I know that if I take 12 and I subtract 4, I would remain with 8. If I subtract 4, I would remain with 4. And if I subtract 4, I will get 0. So it means that I can subtract 4 from it once, twice, 3 times. So the answer is 3. Right? Now, obviously, you're not going to do that in your head all the time, but you would remember from your multiplication tables, if 4 times 3 is equal to 12, then if I take 12 and I divide it by 4, I will get 3. And if I take 12 and I divide by 3, I'm going to get 4. So that is what you can learn from your multiplication tables, and you don't have to think about it this way often. All right? Then we're looking at fractions. All right? Now, fractions, it takes a little bit, and as long as you do multiplication properly, you have no issues. So let's say, for instance, you have 2 on 3 divided by 4 on 5. Then all you have to do is rewrite the problem. So you're going to put back your same 2 on 3. You're going to change the division symbol into a multiplication symbol, and you're going to invert the fraction at the end. So instead of 5 on 4, you're going to get, sorry, instead of 4 on 5, you're going to get 5 on 4. Right? Notice the 5 went to the top, the 4 went to the underneath. And then you can use whatever method that you prefer to solve this one. So it's either you do the cancellation first and then multiply, or multiply and then cancel. I like to do the cancellation first because it's easier. Right? So I divide the top there by 2, and I take out the 2 from the underneath, and that is 1 by 5, which is 5, and then 3 by 2, which is 6, and that's the answer for that one. So let me just put a little note, which is multiply by the reciprocal of the divisor. Right? So I am taking 2/3 and I'm dividing it by 4/5. So all I need to do is take this 2/3 and multiply it by the reciprocal. Reciprocal means the flip of this. So flip it and then you multiply it. Right? And that gives you your answer. Next, let's go to the last one, which is the decimals. All right, let's go to the decimals. And the decimals, let's say the example is as follows. The example is 6.4 times, well, sorry, not times, divided by 2. Right? Usually what I like to do is I like to write this over as a fraction. So I will write it over as 6.4 over 2. And then what I like to do is I like to divide each number. So I'll take 2, into 2 is 1. And then I'll say 6 divided by 2 is 3, no remainder. So I carry 0 over here. And then that 0, 4 means 4. So 4 divided by 2 is 2. And my answer is 3.2 over 1, or 3.2. Let me just do another example so that it looks a little bit more difficult. Let's say we have 7.1 divided by 3, right? 7.1 divided by 3. 3 into 3 is 1. 3 into 7 is 2. I have 1 remainder. Carry that over here. 11 divided by 3 is 3 3s and 9. I put a 0 at the end here. You know what? Let me just write this a little bit differently. So let me see, 7.1 divided by 3, right? So I'm taking 3 into 3 is 1, so I'm going to have 1 on the underneath. And then I'm going to have 7 divided by 3 is 2, and a remainder of 1, so I put the 1 over here. I put the decimal point, and then 11 divided by 3 is 3, and the remainder after that is going to be 2. And then we have 6 3s are 18, and then I'm going to put the next 0, and I'm going to get 2, and you're going to notice that the answer is going to repeat 66666 recurrent. All right, so that's a recurrent number. Good. So the answer is 2.36 recurrent. Okay. The other way that you can do it, just simply move the decimal points. Right? You move the decimal points. Let me just add a new page. Let's say we go back to the 6.4 over 2, right? The fraction form. You move the decimal point. So you see in one decimal place. So if you move that decimal place one position, you're going to have to do the same thing here and add a 0. So this means 64 over 20. And when you do that division, so you could simplify this entire division, and what you would end up with is you would end up with 3 to give 60, and then 4 over that will give you 0.2. Right? You can do that division on your own, and you can see you get the same 3.2. And that's the end of the operations.